Flask is charged with 1.5 atmosphere of N2O4 and 1 atmosphere of NO2, and the following equilibrium is achieved. N2O4 decomposes to 2NO2. After equilibrium is reached, the partial pressures of NO the partial pressure of NO2 is 0.512. What is the equilibrium partial pressure of N2O4? And calculate the Kp for the reaction. Okay, so we're not given the equilibrium concentrations, we're given the initial concentrations. Okay, so whenever you have these types of questions, it's really useful to construct an ICE table. ICE table, and ICE stands for initial, change, and equilibrium. What that is what ICE stands for: initial, change, equilibrium. So to construct an ICE table, you write the equation on top, and then on the left side you write I. There's a row for I, there's a row for C, and there's a row for E. Initial, change, equilibrium. So what are the initial values? Initially, N2O4 is 1.500, and initially NO2 is 1.00. Okay, so this is where the analysis comes in. So we let X be equal to the amount of N2O4 that reacts. So X amount of N2O4 decomposes, so minus X. On the reactant side, the amount of the reactant decreases because it becomes product, so it's minus X. And you look at this, you look at the balanced equation. The molar ratio is 1:2. So for every 1 N2O4, you produce 2 NO2. So if you consume an X amount of N2O4, that means you have produced 2X of NO2 because it's 1:2. So now the equilibrium values, the equilibrium value for each one is the initial minus the change for the reactant, and then the initial plus the change on the product side. So this is 1.5 minus X, and this is 1.0 plus 2X. Alright, so what else are we given? It says that after equilibrium is reached, the partial pressure of NO2 is 0.512. So this here 1.0 plus 2X, the value of that then is 0.512 atmosphere, because that's the equilibrium pressure of NO2. Okay, so then we can solve for X. Solve for X. So 1.0 plus 2X is equal to 0.512. Alright, so subtract 1 from both sides. Minus 1.0 minus 1.0. 2X is equal to negative 0.488, and divide both sides by 2. X then is equal to negative 0.244. Alright, so now we are ready to answer A. Equilibrium pressure of N2O4 is equal to, according to the ICE table, is 1.5 minus X, so that would be 1.5 minus negative 0.244, and that would be 1.744 atmosphere. And part B, calculate Kp for the reaction. Kp, so Kp is equal to the partial pressure of the products minus the partial pressure of the reactants. NO2 squared, because the coefficient is 2, over the partial pressure of N2O4 raised to 1, because the coefficient is 1. And these are at equilibrium. So plug in the values. Partial pressure of NO2 at equilibrium is 0.512, it's given, squared, over partial pressure of N2O4 from our calculations is 1.744 raised to the first, and you should get 0.15.